Hey, sixth grade. Our screencast today is on substituting to evaluate addition and subtraction expressions. So our objective is I can develop expressions involving addition and subtraction from real world problems, and then I can evaluate these expressions for given values. And for our opening, we're actually going to pretend like my sister Kim and I were born on the same exact day of the year. She's still older than me, but we'll act like she's exactly 2 years older than me. That means on the day I was born, my sister's second birthday was happening. So when I was 0 years old, 1 day old, like just born, she was 2 years old. Sharing a birthday is fun, but also a little annoying. And every year on our birthday, we have a party, which is fun, but she's always bragging that she's 2 years older than I am. And when we were younger, that was a little annoying to me. So I made a table for our fake birthdays where we see our ages starting when I was born. When I was 0, she was 2. When I was 1, she was 3. When I was 2, she was 4. And when I was 3, she was 5. When I was 4, she was 6. We can use this table to figure out some expressions work. So if we look at this table, what patterns do we see? We see that my sister's age is always 2 years older than my age. How about on the day that I turned 8 years old, how old was my sister? Think about it in your head. On the day I turned 8 years old, my sister turned 10. And we figured that out since my sister's age is always 2 years more than my age. We just add 2 to my age. So 8 plus 2 equals 10. How about the day that I turned 16? How old was my sister? She was 18. And we figured that out because my sister's age is always 2 years more than mine. So we would add 2 to my age. 16 plus 2 gives us 18. We didn't even need to extend this table. We could just figure it out using that pattern. But what if we didn't know how old I was? We could use a variable for my age. So we could use y for my age, and an expression to describe how old my sister would be my age plus 2. So my age would be y plus 2. And that would describe how old my sister is. What if I kind of flip-flopped it on us and I said, how old was I when my sister turned 6? Well, I have that here listed in the table. So I can see when my sister turned 6, I was 4. What if I asked when my sister was 15 years old, how old was I? Well, 15 isn't listed here. But I know that if my sister was 15, I would be 2 less than her, right? So if my sister's 15, I am 13. My age is always 2 years less than my sister's. So if you know my sister's age, you can determine my age by subtracting 2 from my sister's age. I could use the variable g to represent my sister's age, or k or m or whatever I pick. And so if my sister's age is g, then mine will always be g minus 2. Let's pretend like I wanted to know if my sister was 22 years old, how old would I be? Try and get an answer in your head or on your paper. If my sister is 22 years old, I could use this expression here, g minus 22. I'm sorry, G minus 2, I could plug in 22 where I see a G, and so 22 minus 2 equals 20. When my sister is 22, I am 20. And so we could use our expressions here to pretty much figure out at any age. When I'm 100, when she's 80, we could figure out how old the other one would be. Okay, so we're gonna move on to a different problem. We'll call this one exercise 1. And let's try a newer kind of problem that's not about birthdays. So let's all draw this table, and I'll explain it as we're going. So we have the school day, the number of box tops that Noah has, and then the number of box tops that Carter has. And let's go through this problem. So Noah and Carter are collecting box tops for their school. They each bring in 1 box top per day, starting on the first day of school. However, Carter had a head start because his aunt sent him 15 box tops before school began. So you can see here, Carter on the first day of school brought in 16 because his aunt gave him 15 plus he had one of his own. So he started with 16. Noah's grandma saved 10 box tops, and then Noah added those to his 1 box top on the first day of school. So Noah brought in 11 his first day, and Carter brought in 16 his first day. On the second day of school, Noah has now brought in 12 because he brought in 1 more box top. Carter has brought in 1 more box top also, so he has 17. So we can say on the 3rd, 4th, and 5th days of school, we know how many box tops they brought in. And we can use this table to help us figure out some questions. So if we let D be the number of days since the new school year began, on day D of school, how many box tops will Noah have brought? Noah will have brought D plus 10. It's whatever number Noah himself brought plus the 10 that his grandma gave him. And on day D of school, if we wanted to know how many Carter has brought in without the help of his aunt, we would have D, the number that Carter brought in on that day, plus 15. And that makes sense because if it's the 5th day of school, and I said I wanted to know on the 5th day of school how many box tops did Noah bring in, then I could do 5 plus 10, and I see that it's 15. I could do 5 plus 15 and see that Carter brought in 20. On day 10 of school, we could figure out how many box tops Noah will have brought. On day 10 of school, I would plug in or substitute 10 plus 10, and I would know that Noah has brought in 20 box tops. And if I wanted to know on day 10 of school, how many box tops will Carter have brought? Well, I would do 10 plus 15, and I would know that Carter brought in 25 box tops. Let's try another problem. We'll call it exercise 2. And this one has a very detailed descriptive chart. So we have the week, we have the total amount of paper recycled by the primary school this year in pounds, and then the total amount of paper recycled by the intermediate school this year in pounds. Okay, so let's get some context on this story. Each week, the primary school recycles 200 pounds of paper. The intermediate school also recycles the same amount, but had another 300 pounds left over from summer school. The intermediate school custodian added this extra 300 pounds to the first recycle week. So the first week, week 1, you can see that the primary school recycled 200 pounds. The intermediate school also recycled 200 pounds, but they had 300 pounds left over from summer school that was added. So 300 plus 200 means that they started out with 500 pounds. And then you can see week 2, they each add another 200 pounds. Week 3, they each add another 200 pounds, and 200 pounds, and 200 pounds. If this trend continues, what will be the total amount collected for each school on week 10? So now we want to know for week 10, how many pounds will the primary school have recycled and how many pounds will the intermediate school have recycled? Well, the primary school will have collected 2,000 pounds and the intermediate school will have collected 2,300 pounds. And let's talk about how we got that. So, what I see here is that we're just adding 200, 200, 200, 200. But if I wanted to know for week 30 or week 500, it's going to take me a long time to just keep adding 200 at a time. So I'm trying to figure out the relationship between this column, and this column. Let's pick a variable to represent the amount of weeks that has gone by. So we can pick any letter times 200, and that'll give us the number of pounds. So we need a letter times 200, and that will give us the number of pounds of paper recycled that week, or the number that is listed in this column here. If I do the first week times 200, I get 200. If I do the second week times 200, I get 400. If I do 3 times 200, I get 600. So this pattern is working. And if I try it for this side over here, 1 times 200 does not equal 500. So I'll have to write a different expression for this side over here. I can figure out, however, that this expression makes sense for primary. So let's start here. If I did 10, the 10th week, times 200, that would give me 2,000. So that would help me figure out that on the 10th week, the primary school had 2,000 pounds of paper. Let's just pick W for our variable. I noticed between this chart and this chart that we had an extra 300. If I add 300 to what I have here, I get what the intermediate grades had. So 200 plus 300 is 500. 400 plus 300 is 700. 600 plus 300 is 900. That's true for all of these. 2,000 plus 300 is 2,300. So if I take this expression that we just wrote and add 300 onto it, I add on an extra step, then that'll give us the intermediate number of pounds of paper. So this only works for primary. In fact, I'll color code that up here. That only works for primary. For intermediate, I would have to do the number of weeks times 200, do that first, so I put it in parentheses, then I add 300, and that gives me the number of pounds per week for intermediate. So in this problem, we end up having two different expressions to figure out the information that we need to have. And so we'll look at one more exercise, and this is exercise 3. We have Kristen's age in years and then Shelly's age in years. So when Kristen is 0, Shelly is 5. When Kristen is 1, Shelly is 6. When Kristen is 2, Shelly is 7. And when Kristen is 3, Shelly is 8. Shelly and Kristen share a birthday, but Shelly is 5 years older, as you can see from the table. If Kristen is 16 years old, how old is Shelly? If Kristen is K years old, how old is Shelly? And if Shelly is S years old, how old is Kristen? So I'm actually going to write these out for you and then see if you and your team can problem solve. I'll put the answers in this presentation so that you can figure out with your team if you were correct or not. So I want to know if Kristen is 16, how old is Shelly? I also want to know if Kristen is K years old, how old is Shelly? And I want to know if Shelly is S years old, how old is Kristen? So I'll leave those for you and your team to problem solve. I'll put the answers up at the very end of the video so you'll see the closing first and then the solutions to those problems, and you can see if you were on the right track or not. But first, before you start that with your team, here's the closing. So there are two questions. Why were we able to write these expressions? And what is important to remember about labeling your columns in a table? So I have some sample answers for you for the closing. You can jot down your own ideas, but the sample answers look like this. We were able to write these expressions because there was a relationship between the two quantities that we could identify. And it is important to remember that the label should be complete with units so that the reader understands precisely what is meant by the chart. And so now I'm going to show you the solutions for these problems here. And you can see how you and your team did problem solving. So if Kristen is 16 years old, how old is Shelly? 21 years old. If Kristen is K years old, how old is Shelly? Shelly is K plus 5 years old. And then if Shelly is S years old, how old is Kristen? Kristen is S minus 5 years old. All right, thanks so much.